Network automation is one of those CCNA topics that a lot of students underestimate at first. It sounds advanced, it can feel intimidating, and it's easy to think you'll deal with it later. But once you see how modern networks are managed, you realize this is exactly the kind of skill that gives you an edge on the exam and in the real world. We're going to make this practical from the start. You'll see why automation became necessary, how SDN changes the way networks are designed, and why APIs, JSON, NETCONF, RESTconf, and Ansible matter to you as a future network engineer. By the end, the whole path should feel a lot more connected and a lot less intimidating. When you're managing a few routers, doing everything by hand is just annoying. When you're managing hundreds of devices across real production networks, it becomes a serious operational problem. Every repeated change takes time, and every small mistake can turn into downtime, tickets, and hours of cleanup. One engineer makes a late-night change. Someone else misses one line on the backup device. Suddenly you've got config drift, hidden human error, and a compliance problem waiting to show up at the worst time. Think about a merger or a big rollout. Now imagine repeating the same update across dozens or hundreds of devices by hand. It's slow, easy to break, and frustrating to verify afterward. That's exactly where automation starts to feel like a payoff. You define the task once, run it the same way every time, and get faster changes, more consistency, and fewer mistakes. And once you see why automation matters, SDN starts to make a lot more sense. In a traditional network, each device makes its own control decisions and maintains its own local view of the network. With software-defined networking, more of that intelligence is centralized. A controller has a broader view of the network, so it can help apply policy and coordinate decisions across the environment instead of leaving every device to work alone. That means better visibility and more consistent policy enforcement. You're not counting on every single device to be configured perfectly by hand. It also makes provisioning much faster. Instead of logging into devices one at a time, you define the intent you want, and the controller helps drive the network toward that outcome. Here's the simple way to keep this straight. Think in 3 planes: data plane, control plane, and management plane. If you can separate those 3 jobs, SDN gets much easier to understand. The data plane does the actual forwarding. This is the part of the device, often using ASICs and other hardware logic, that moves packets based on information the network has already learned. The control plane is the decision-making side. This is where routing and switching protocols build tables and determine where traffic should go before the data plane forwards anything. The management plane is how we access and manage the device. Think SSH, SNMP, NETCONF, and RESTconf. Now add the controller back into that picture. In SDN, the controller becomes the central point for logic, policy, and visibility across those planes. Applications communicate with the controller through northbound APIs, often REST APIs. In practical terms, that's how software asks for information or tells the controller to automate a task. Then the controller communicates down to the devices through southbound interfaces. That might be something like OpenFlow or management protocols such as NetConf, often structured with data models like Yang, so everything stays consistent. For the CCNA, Cisco DNA Center is the enterprise example to remember. It's a real-world picture of how centralized policy, visibility, and automation can be used to manage a network at scale. Now let's shift into REST APIs, because this is where networking starts to connect directly with modern automation skills. If you're learning network automation for the CCNA, API basics matter. In REST, network objects are treated as resources, and each resource has its own URL. So a controller might expose devices, interfaces, or policies through separate endpoints you can query or update. REST is stateless, which means each request has to bring what the server needs right then and there. In practice, that usually means things like an authentication token and the correct headers such as content type. And when those APIs send data back and forth, JSON is usually the format you'll see. That's why CCNA automation keeps linking APIs and JSON together. For the exam, tie HTTP methods to CRUD. Get reads, post creates, put or patch updates, and delete removes. If you remember that mapping, you're in good shape. Get is usually for asking for information back, so it typically doesn't need a request body. Post usually sends data because you're creating something new. Put is usually treated as idempotent, so sending the same request again should leave the resource in the same state. Patch is typically used when you're updating just part of the resource. Status codes tell you what happened with the request. 200 means success, 201 means something was created, and 204 means the request worked but no content came back. If you see a 400 level code, focus on the request. 401 usually means authentication, 403 means you're authenticated but not allowed, and 404 means the resource isn't there. A 500 level response usually means the problem is on the server side. So first read the code, then decide whether you need to fix your request or troubleshoot the service. Now we get to JSON, and this one really matters because it's everywhere in APIs and network controllers. If you're learning automation, you need to be comfortable reading it. At the most basic level, JSON is just key value pairs. A key like hostname might have a value like branch R1. Those values can be strings, numbers, booleans, nulls, or arrays if you need a list. JSON objects can also be nested inside other objects. That's how detailed device information gets organized without turning into one giant flat list. Imagine a controller returns JSON for a single device. You might see the hostname, management IP, platform, software version, and whether that device is currently reachable. If the response includes interfaces, that part is often an array because one device can have many interfaces, not just one. In simple terms, you read a top-level value by its key. If that value contains another object or an array, you keep drilling down from there. So, if you want the host name, you go to that key. If you want the first interface name, you go into the interfaces array and pick the first item. That's the basic idea. Next up is NETCONF, and this is more important than it first sounds. For the CCNA, know it as a standards-based way to manage configuration over SSH using structured XML data. Instead of logging in and typing commands one line at a time, a client can use operations like getConfig and editConfig to read or change structured configuration data. NETCONF also gives you safer ways to make changes. With a candidate data store, commit and rollback, you can stage a change, apply it deliberately, and back out if something goes wrong. Yang is the data model that gives all of that structure. And Cisco IOS XE is a real platform where this matters both in production networks and on the CCNA. If there's one automation tool to really lock in for the CCNA, it's Ansible. This is one of the highest value automation topics to remember because it's both exam relevant and widely used. Ansible is agentless, so you don't install a permanent agent on every device. It usually works over standard access methods and pushes tasks from a central control node. Its playbooks are written in YAML, which keeps them readable. And because Ansible is designed to be idempotent, running the same automation again shouldn't keep making unnecessary changes. You'll also want to recognize modules like ios_command and ios_config along with inventory files, roles, and Jinja2 templates that help you scale repeatable workflows. There are plenty of other tools in the automation world, but for CCNA purposes, you don't need deep mastery of all of them. Know the landscape, then keep your focus on the tools the exam emphasizes most. Puppet and Chef are configuration management tools. Terraform is known for infrastructure provisioning. They're worth recognizing, but for CCNA, they matter much less than Ansible. You might also hear about Python tools like NetMiko or Nornir. They're useful to know about in real automation work, but for the CCNA, keep Ansible as your main anchor. Before you move on, lock in the big picture. You want the 3 planes clear in your head, the SDN controller model solid, the REST methods and status codes familiar, and JSON readable at a glance. So as you head into the next lesson, keep the core automation toolkit in mind. Understand NETCONF and RESTconf, keep Ansible front and center, and you'll be in a strong position for both the CCNA exam and real networking work.